So it's running, and I can put in a word, cow. Let's just make sure I don't have anything in the data store already. So there's nothing in there. And definition is moo-moo. And now if I look in my data store, I've got under kind, word. I have cow, definition is moo-moo. And the term is cow, definition term. And the key is cow. Right? I gave it the key of cow. Right? So right here, this definition and term came from this. Right? That's part of my data that I'm storing. And then the key came from right here. Right? Same thing, it's just the word, cow. And so that became the key. That's the key. So if I want to access that data record, cow, cool. So we could that's storing something with a string as a key, right? And now here's another one storing with a string. Oh, this is getting. So I can now get the word out. So there's my data structure, and index. I'm setting my header, and if it's post, I'm going to put the word. And what does put word do? Gets the term, gets the definition, gets the context, new key, puts the term, creates a variable of type word, and uses a composite literal to assign values to the fields. And then data store put context key entity, right? Here's the key. Data store new key, context, the kind, which is like the table, put it in this table. This is the key. It could be either a string or an int 64. And then this would be if it had a parent. So parent just means, is it in a parent folder? You create folder-like hierarchies. And we'll talk about parents and children and ancestors, descendants here in a second. So parent, ancestor, child, descendant, interchangeable words that you'll see in the documentation. So that's just put word, if it's post.
Majority of your things will not have a parent. Some will, but a lot of data, you don't need a parent for it. You just put it in a separate kind.
And if you do have a parent, it limits your right. There are implications. So here, request URL path, favicon not found, and then if it's not equal to this, it means, hey, we've asked for a word, we've appended it to the end. So show word. And here at show word, get the context, get the URL path, and we're going to split on the /. And so what will be in position 0 will be right what was at the front of the /. Position 1 is everything after it. So it gives us back a slice of string. So give us an index value 1, not 0. And that gives us the term. And then we get a key. Context, word, getting the same key, right? If I put in cow. And then we say data store get, context key, and that entity created a variable entity of type word, put the results into there. And then if there's no such entity, not found. If there's some other error, server error 500, right? And maybe I should change that to http.server internal server error. Is that the 500 one?
Yep. Yes.
500. And then I just print out that term and definition. So this is like totally cool. Like you're in business right now as a software developer. You could build a web page and you could take people's data from a form and store it, and you could take it and you could display it. Awesome. And it's going to scale. Awesome. And there's a little issue about eventual consistency. We'll figure it out.
So this is where the UUID is really nice. If you stick a UUID in someone's cookie for their login, you can now just use that UUID as your key for data store get, and then have your struct be any user data you want to have.
What other animals do we find on a farm? What's your question?
So when you're putting stuff in and out there using the context, so it's like the stuff, is it only there for that one context, or is it like a separate instance of the data for each context?
Like, so is it
No.
associated with a single user? So if a different user is in there, would it only get
It's-
certain data?
It's part of the way App Engine works. They're running in like a very restricted virtual machine, and the context also includes the one connection they've got to the rest of Google's servers, which actually has access to the database. So they have to have it, because if you just do http.get, it will actually crash because your App Engine app does not actually have access to the internet except through the context has one connection. So yeah, it's a shared database between all the different ones, but they need the context in order to get to the one link they've got with the outside world.
What's another animal we might find on a farm?
Log.
Pig. Oh, pig. We might find the farmer. We'll have to do the farmer next. Submit. Come back here. And there's a refresh. Where is it? Listen to these. Now we have cow, capital, and we have pig, lowercase. Right? So now I should be able to go here, / capital cow. Moo moo. Pig, lowercase. Oink oink. What happens to cow, lowercase? Not found.
Looks like you forgot to return after you said not found.
I think I did.
Yeah, there.
Cool, huh? Lowercase didn't work.
It should auto refresh the Go app serve.
That's O2. And then instead of using a string, we could use an N64 to put something. So, same thing, put word, function I created, show word, return.
I think it's in show word is where it's got another not found.
Yeah, I think I forgot that one in this one too. This screen is very, no, that one's good. And return there. Three. Put word, favicon, show word, print line, put word. So here we have I've created a variable counter, and I've given it, it's of type int64, and I gave it a package level scope. And so when I create var int64, that's going to set it equal to its 0 value. Zero. And this is a little bit funny. I could do counter plus plus. Zero, one. And then people from other languages want to do this. I already have that copied. Oh, I don't. That's because counter plus plus is a statement, not an expression. And you could go look at the Golang FAQ.
There's a drop down menu right there.
Huh?
That's a button.
That is crazy. I'm like on mobile.
That actually looks like
There we go.
actually looks like it's using Bootstrap or something.
Boot crap. Documents. Frequently asked questions. Plus plus. C plus plus. Why are plus plus and minus minus statements statements not expressions, and why postfix not prefix? And because it makes things better and simplifies things on the back that we don't want to. It makes things faster. So you can read about it. I see some of you are wanting to read it right now. I'll pause. I thought I highlighted that and already read it. It's not kicking in.
If they've changed the website, your plugin may be unable to identify what.
Oh, that's true, huh?
Why are plus and minus statements and not
So
expressions?
So it's a statement. It goes on its line. It's a command by itself. An expression would be something you could put inside like an arithmetic operation.
Yeah, I'm asking that, but is that trying to say is not also a statement?
So yeah, they're both statements, not expressions. So in C++, they're expressions. You can put them inside a math statement, and they'll do their thing as well as give a value out for the rest of the equation. In Go, they're statements. They go on a line by themselves, same as like an assignment statement or a function call statement.
That's not exactly what I was asking, but that English doesn't seem very good.
It's very precise, technical.
Why are plus and minus statements not expressions and not expressions? Sorry, just
Which one?
The question.
Why are plus, minus statements and not expressions? And why postfix, not prefix? Yeah, no, reading the documentation is an exercise in haikus or something. They're not always clear. All right, so this was just to illustrate here. I create this variable var counter in 64, and then down here I increment counter plus plus, and I'm going to say my key is now will be 1, and then it'll be 2, and then 3 as I add words. And I'm using an empty string here, meaning I don't want that for my key. And then nil, no parent. So new key. And so that's 03. And go app serve. And now I could refresh this page and do a new word, farmer. What do farmers say?
hello. Expletives.
What was that thing from that pig farmer? Like, you're a good pig.
I hope it rains.
I hope it rains. That's good. Or I hope it doesn't rain. And I'm going to take that out. That might throw off my parsing. All right. And now list entities. And now look, just on the fly, we've changed our schema. Some of the words are stored with a key that's a string. Some of the words are stored with a key that's a int64. And if I add more in, cat, meow, meow. And then I could start, you know.
Go to /1. It's going by key.
Key.
Your code is
Because my code doesn't count for it. My code only works for this. Because now my code, when I say show, I'm putting in an int64. I'm not sure if I could have cleaned this up, but I got the X out of the URL, and then I said convert it to an int, ASCII to int, and I got Y, and I said convert that to an int64. Was there a more succinct way to do that anybody knows about?
There's another string convert that gives it back as an int64 in the
Oh,
first
does it?
place, but it requires a lot of. It's like a bigger function call.
All right, so that's fine. So I get a new key, and I say data store get, and I pass in that key. So if I wanted to be able to catch either a string or an int, because I built my application and changed my schema for how I'm storing data partway through, it's schemaless, meaning I create my own schema. And at the beginning, my schema was to store with strings, and then I switched halfway through and started storing with ints. So I'd have to write my code to check, is this a string or is it an int? and then pull that one.
It'd be pretty simple, actually. You've got that A to I returns an error. If it's an error, if it gives an error, it's a string. If it's not an error, it's the int.
I feel the urge.
So if there is an error, it's a string. So just do the new key and pass it into x in string value in 0. So yeah, that's.
All right, so that's if error, then the key is going to be
A string. So
that would be this would be 0, and this one would be
x.
x.
Yeah, from line 79 and go in the else clause.
And else.
Autocomplete is
I know it's
annoying.
interfering me. There we go. And I need to declare my key up here.
Yeah.
Bar key, and I got to see what it is. It's
a pointer to a data store.key.
Pointer to data store.key. Boom, boom. Cool.
And now 84 is saying that you've already got an error variable.
And that should all be rebuilt. So now I should be able to put in cow.
Oh!
Then you have to restart it. So that's a new key for a string, and then you can do a new incomplete key. So instead of when we had new key, we did context, we did kind, and then we either did a string or an int. Those would be the next two, right? Here's new incomplete key, right?
New key's down low.
New key, yeah, here's great. I put it in already. New key had either a string or an int for the key, and then nil. New incomplete key means we just put it up there and it creates the key for us. So let's see that run.
It'll give a nice random number for your key. Usually. I think it's usually a random int.
And I could change it after I launch it. There is those errors again. Post, any errors, return. Oh, sure, okay.
Using different.
And word, dog. Woof, woof. Submit. Listening to these. Now it just randomly gave me one.
It does have a little some guarantees to keep you from having colliding keys. You don't have to worry about it randomly choosing a number you've already got. It does have a guarantee on that. Although N64 does have a ridiculously large space, so that would be pretty rare anyway. But just in case, it does check and make sure it doesn't accidentally overwrite a key you've already got.
And new incomplete key gives you a random int, correct? Not a random string, or is it a random?
It's undefined. It's App Engine can give either. Basically, you say, I don't care what the key exactly is, just put it into the database. I've got my own way of getting it out later.
So new key, string, N64, incomplete key. And then here's two examples from the documentation. And then how do we get things out? So we could pull things out. We were doing it with get, but you could also do a query and iterate over all your results. So let me just show you that. So there's my type word.
Return after your favicon.
There you go. And set my header, and if the request method is post, then put the word, and then there's my form, and then here's put word, and which one does there's the index. Okay, words will show the words, so show words is coming up. Put word, So we put it, and we're doing a new key, our own key, and then put, and then in here show words, we create a variable HTML, and it's equal to an empty string. I think probably the more idiomatic way would be this. And then do a new query, data store new query of this table, this kind, word, right, that table. And we're assigning that to Q. And then we get our context. And then we do Q run context. Right, so we run it and we get this iterator. That's just the variable name. And then we do a loop. And this is going to loop forever until we get to data store done. And then we're going to break out of it. And that's what you get, the error you get when you do this iterator next. You get that error, and if it's data store done, you break in this loop. And then it's just iterator next and put the data into that variable. Right here, var entity word.
You also need to change the 500 to the HTTP .com.
HP internal status, internal server. So yeah, the iterator just kind of go. You call next on the iterator with a pointer to a struct that you wanted to fill out, and each time through it'll fill it out with a different thing from your query. So in this case, we're just doing a general query, anything in this table, give me everything. Usually you put limitations in. In this case, we're just saying every word. We're going to query for every word, everything in the word kind. Iterator.next will return an error as a part of its thing. That error will be datastore.done if it's gone through everything. It'll be something else if it's an actual error. So that's what this if is for. If it's a datastore.done, that means we've successfully found everything. We can break out of our infinite loop because we found everything. Else if error is not equal to nil, then it's an actual error. We need to report this and then get out of the function, stop trying to continue. And then otherwise, we've got our HTML plus equals. We've got something successfully out of the data store with our query. Let's add it to our HTML, which typically you would be using a template, not just direct HTML. We've got our cross-site scripting issues here.
Nice.
So the query is kind of like asking for the next words, the next word in the words table.
Yeah.
So
usually you put in limitations on your query, like query only if the name is this thing. So this is basically, we don't know what our key is exactly. Let's look for it.
So it's similar to like searching for something on a server.
Yeah.
new query creates a new query for a specific entity kind. Interestingly, you could have an empty kind, means return all entities, including entities created and managed by other App Engine features, and it's called a kindless query. Kindless queries cannot include filters or sort orders and property values. So basically, this is to like query this table. You got all the results from that table right there. Right? Now we're creating the query, now we're going to run it. We pass in the context. That gives us all the results, right? So we create the query, this is what the query is, it's going to query that, and then we run it, gives us all the results. And then iterator, well, this next thing, this could have been called anything, but next we'll pull out the next result, the next result, the next result. And we got to loop over that some way. So you could have done this with some other loop structure.
Yeah, it may not be all the results immediately. Query.run will start the query and start getting responses back. So it'll quickly be able to hit the next, but it may still be getting more results as you're running.
What's the first thing that it's returning that we're
The what? The first thing it's returning?
Yeah, the iterator.next is returning.
Oh, the underscore?
That's a good idea.
I don't even remember. Oh, the key.
Key.
So it gives you back, you give the pointer to some value it wants to fill up, it'll also return the key to that in case you want to look that thing up later more efficiently. That would be how something you could throw in the Memcache, as we were saying at the beginning.
Yeehaw!
Or if you were querying over like a set of like counters or something, you could go through with query to get them all and getting the keys, and you can use that to put something in and overwrite it if you wish. So slash words have the query runs the query. So code has no idea what the words are. We just run a query. Say, hey, give me all the words.
And on this query deal, you could add a dot, order, count, distinct, right? So I could sort them with order here. I could limit, just give me 10. I could just run it straight there, right? And get all the results. So data new query run, or data store new query on the kind word keys only, or distinct, or order it by, alphabetical each term. So we could add parameters
you
there.
might want to demo that one.
Which one?
The
Order? Order. Field name. What's my field name? It's a string. My field name is term, capital T. Okay. So here we have farmer, cat, dog, cow, pig. Not alphabetical, right? What should we see first? Cat. What should we see last? Pig.
Well, cow may come first because it's capitalized.
Oh, thank you.
So it's going by ASCII order, ASCII, and so capital letters come before lowercase letters. So and then if you can change it,
We could fix that.
you can change. Yeah, you can fix it. No, you cannot.
Oh, because the key is cow.
Yeah,
But the term is lowercase.
but it's searching.
So maybe because we
but it
said
is-
term.
But yeah, we are searching.
There we
for
go.
term.
We said order by term.
So and then you can set it to negative term in there if you want to do reverse alphabetical order
Is that?
inside the quotes. It's a string argument.
Oh, thank you.
There you go.
And we could say limit 2, 3, and then order them.
Make sure you pay attention to your order that you put in those query things, because
Limit before you sort.
yeah, depending on which order you do them in, you may get different results back. For example, if you limiting before sorting, you may not be that may not give you the last 3 alphabetical order.
Oh, because it'd just take give me 3 and then order those 3 versus
Yeah.
order them, then give me 3.
Yeah.
Hmm.
So keep track of what order you do your filters there.
So if we'd stored date here, like time from package time, type time, we could get the 10 most recent. I think that's one of the examples in the one we were looking at Monday. So it's kind of cool because we've been learning all this foundation stuff, and I feel like here it's not a very big stretch, and you just got a lot of power. You got a lot of functionality. And then we have this deal where we could do parents.
Okay, so yeah, the parents have got implications. If you have something that has got a parent key, it's basically you've got a key and it's got another key as its parent, and that can go back as many ways as you wish. If you have a parent key, it will be strongly consistent, but you are limited to 1 access per second. Or is it 1 write or 1 get? Or is it just, I don't remember.
One write per second.
So yeah, 1 write per second, but it is strongly consistent.
Which, when you look and you say this took 6 writes, does that mean 6 seconds?
So, no, I think it's 1 for the putting in, and those other 6 are for updating the search index.
Yeah, so ancestor queries are strongly consistent, but your throughput for how many writes you could have per second sucks. It's 1 per second. So generally stay away from ancestor queries. Unless you got something that's not going to be hitting fast, it's not going to be a lot of people, right? And
So,
you need to be
can
strongly
query and get it
consistent.
from it as much as you want. It's just writing to it's going to be slow.
What is the ancestor of this folder? 06?
Whatever folder.
Yeah, 054, right? That's its parent. So that's the exact same way you should think about parent, children, ancestors, descendants, and app engine, right? It's like a folder, and it's got a bunch of kids in it, right? Or descendants. So here I did tools, right? And I'll just run this. The code's pretty similar. The only difference is here for data store new key. This is the key for the tool. It's going to be kind tools, and the key is going to be whatever the name of the tool is, right? So string, it's a new key, not incomplete key, and I give it a parent key. So it's now saying, hey, the parent of tools, kind tools, table tools, is house. Or in the house folder, there's tools folder.
House is the kind. Garage is the
House is the kind. Garage is the
actual key.
key. All right. Kind. Garage.
So ancestor, anything having to do with the ancestor is strongly consistent, but your write speed stinks. Why would you use it anyway? Well, for one, you have strong consistency, which is nice. And then for two, if your query has an ancestor filter on it, it is much faster than just generic querying. So if speed's an issue, a query that has an ancestor as a filter will go faster. So, because, for example, for this house example, which is faster to find all the tools in the garage, which is faster, just search the garage, or find all the tools in the entire house and then get rid of everything that's not in the garage?
I'm guessing it's the first option.
Yeah, just search the garage. Same idea with a query that's got an ancestor filter.
Now I have two kinds. Tools. And if I look here, I see it's in parent house, name equals garage. So I'm confused a little bit, but this is, okay, here's my context, here's my kind, which I think of as a table, here's my key. So here is my context, here's my kind, so that's the parent, right? And then the key for it is garage. So that's kind of like in this folder, there's another folder, or the folder analogy breaks down.
House would be the table with the garage entity, but there's no data associated with garage by itself.
Okay. All right. But we're going to see I could also do kitchen tools here in a second.
So hang on. So the garage folder does not have any tools in it?
No, it's you've got tools that are assigned to with garage as its parent, but you don't have anything in garage like a struct actually assigned to the garage key by itself. We could put like a struct that's got like color of the walls of the garage or something and put it into the garage key, but we don't in this case. Garage is not actually in the data store. It's just the parent of, or it has no data in the data store for it. It's just the parent of this thing.
Yeah, so this is the kind house. This is the kind tools, right? The parent for this key, which is tools, hammer in the example we just did, the parent is kind house and with key garage.
Have you shown how to the ancestor query bit on that?
Not yet.
That might help.
Yeah, there was the last time, but yeah.
Because the way that these tie together will feel very weird until you see that it's a completely different kind of query.
So if you were to have, say, another parent key called house, but with type.
Kitchen.
With the
Type
value, yeah, with the key.
We'll see that in a
key
second.
Kitchen.
Let's look at that. So now my form, I could say, hey, is it garage or kitchen? So this is 03. Apparently my definitions are all about sounds. You could see how much I did not get read to when I was a kid. Were, right? Key name, but if the parents on these are going to be different. This is house and then in kitchen.
So this would be useful for, like, say, a forum where you've got a bunch of different threads within the forum, and then they may have posts, and the posts have an ancestor of which forum thread they're in.
And then here's a iterator query for ancestors. Put tool, show tools. Parent key, data store new key, context house, garage, 0 nil. And then data store new query, tools is the kind, and the ancestor is this. So we're getting everything out of the garage. Is that what you meant there, Alan? Does that help see it?
Yeah, so you can see we're querying on table tools, but we're saying with ancestor parent key. Parent key is something completely different in reference to this table we're querying off of. So we're pinging into it and saying, hey, do you have an ancestor, and is that ancestor from this parent key?
So it's if you have a house and you have a table with all the tools within the house, if you wanted to find specific tools for a certain part of the house, then you would say, hey, is your guys' ancestor this location of the house? If it is, then you don't need like 3/4 of that table.
Exactly. It's a way of being a very special kind of attribute. This attribute implies a strong connection between the two tables.
What did I call it?
Please note that the filter is ancestor and not parent. So the ancestor key may be a grandparent, a parent of a parent. There's no just plain parent filter for your queries. It only has ancestor.
Which is still useful
Still
within
useful.
itself.
Yes.
Because as you nest further down, if you want everything of this grandparent, great-grandparent, whatnot, you can still call that.
Usually you only want to have one extra generation
Yeah.
because your 1 write per second is per highest level parent or ancestor. So if you got something, say you got like a tree, where's those markers? That marker. So if you've got some topmost parent here, X, and it's got children who have their own children, you've got 1 write per second to every item in this tree. But say you've got a second tree.
Now, what do you mean by 1 write per second for every?
So if you have parents, if you're using parents at all, you have 1 write per second per group. So you got 1 write per second to this group and 1 write per second to this group. So you only typically are going to want to go down 1 generation, because if you go down 2 generations, it's still 1 write per second all the way over. So if I were to, for example, for here, if I want to write to I and J, it would take me 2 seconds to do it. If I got rid of this X and had X just be something completely off to the side, different, now I could do both of these at the same time because they're different. They don't have a common ancestor.
Just don't make branching tables.
Yeah. So
Yeah.
limit your ancestors as much as you can.
Yeah.
Is the main takeaway. Because anything that's got any shared ancestor, you have one write per second to that group.
Now, by writing, you mean writing to?
You're writing to the data store. So you can query from it and get from it all you want. It's just writing to it 1 per second in a particular group. So in this case, here's one group, here's another group, got another group here, and then all of this is one group.
Yeah, entity group.
Actually, if it doesn't have any parents at all, you don't have any limits. This one's unlimited. So 1, oops, that's 2. 1, infinite. So this group 1 per second, this group 1 per second, that group 1 per second. There's no parents connections whatsoever. You got infinite writes per second. Although if you got a whole bunch of writes per second to something that's by itself, you have no idea which one's going to be coming in last due to the eventual consistency.
Now, what sort of actions would cause something to be written to the server?
Data store output. So for like creating a new user, you'd be putting a new user into the data store. For Twitter account, making a tweet, that would be a new tweet into the data store. Basically, whenever you're changing something in the database, you're writing to the database, so it's got different contents. So your ancestors give you strong consistency, which is the main downside to NoSQL. But you only got 1 write per second to the entire group.
Does it accept the read add-on?
No, read is completely still fine, which is why you'd still bother to use it. Because if you search for all the children of Y, that's much faster than looking at all of them and then filtering down.
So wait, the 1 write per second, does that mean that you only have 1 second to write all that down, or?
No, more like you can only write to the database once per second. And if you got like 3 people trying to write to it at once, 2 of them are going to have to wait. For one of them is going to wait for 1 second, one of them is going to have to wait 2 seconds, depending on what order they all arrive at.
That's up there, not here. Thank goodness.
So yeah, your parent is going. So anything that you're going to use with parent, you're going to want to have something that's not going to change a huge amount compared to how many reads. Which generally you're going to have a lot more writes than you.
Not on my computer, is it?
Writes for most data.
Oh, good.
But it's especially useful for stuff that you're really not going to have too many writes for, like say a forum. If you got a forum, you got many threads. You're not going to have like a million people trying to write to a particular thread in a forum all at once. You're probably only going to have like 1 or 2. So the 1 write per second is not a big deal. You can have lots of people looking through and reading the forum at once. That would be where this would be used.
So it's you going off of that forum example of, say you have like the front page of a forum where you have like the parent links to subforums. Those links,
So you probably
you don't want changing a whole lot because you don't want them to change.
Well,
at
in this
all.
case, you probably don't want to go from forum to subforum because then you'd have them all as one big group. If you've got like your top level forum here, T, and you got a sub threads, and then each one's got some posts,
So
you do not want these connections. Because if you've got these connections, this is all one group, and you've only got 1 write.
So we've talked about this very, very briefly, the idea of flattening your tables.
So yeah, for this, if it's like this, you have 1 group, and that's 1 write. Which this is be that. You want to get rid of these connections here, and then you've got this group and this group.
Mm-hmm.
maybe have a separate kind or something for threads, which has got its own information. Have something over here, T, which has got the keys, maybe. And then now you've got the keys, and you can look up in a different table your separate thread stuff. Data organization can get complex fast.
Yeah.
But
There's some
main
super
takeaway
smart
is-
people out there.
Main takeaway is ancestor queries are much faster, really good for reading, and you get strong consistency. Avoid them when you can, though, because you've got that one write per second. Let me erase the big jumble of lines and letters and such.
So here's an article which is interesting to read. The architecture Twitter uses to deal with 150 million users, 300,000 queries per second. Whoa. 22 megabit per second fire hose, and send tweets in under 5 seconds. Last thing I want to show you, then I want to let you guys go early so Daniel could study, is Memcache. So here's getting Memcache when we haven't set. What happens if we ask for something from Memcache? Memcache get context some key, just key value store, right? And we haven't set that. So what happens when I run that? And that is 04401. Control C, K, change directory 04401. Go app serve, and let's just write an index. Nil. So no errors there. So basically it's memcache get, returns an item and an error. I ignored my error, but nothing. It's fine, right? Printed nil as the item, got nil back. So that's just if you got something that's not there. You could check the error and see, did I get something back or not get something back. How do you set and get things from Memcache? Context. Here's item 1, which is import. Memcache item. So Memcache item, if we look at Memcache item, it's a struct with a key, a value, it has expiration, right, which we could set to. And so a Memcache item, composite literal, key is foo, value is a slice of bytes, bar. So we could set it, and set asks us to pass in context and a pointer to an item. So here's the pointer to the Memcache item, right? And then we could get it, and we're getting it out by key. And so we run on O2. We set it, got it back out.
The 8000 thing shows that has a Memcache tab, I believe.
Oh, thanks.
Memcache viewer. GUI. You have to search for it. What do you call it?
Foo. And see if there's anything else here. So here's playing with expiration. And so again, it might just expire at its own damn volition. But here expiration 10 times from package time a second. So in 10 seconds this will expire, right? So I'm going to run O3 and we'll be able to see this in action. It's kind of cool.
I believe App Engine does give priority to items that got their own expiration date. So if you know that it's not going to be needed after a certain amount of time, then put that expiration date in, and Memcache will make it a bit less volatile. Still volatile, but less volatile.
So I just re-ran that page, and so it set it with an expiration, and then I said show me foo, and now we're waiting 10 seconds, and it's gone. It expired. So I was thinking this might be a good application we could build where people could send pictures of themselves, but then they get destroyed after 10 seconds. I don't know. That's a dumb idea. That would never get used. But people want to do that because they're always sexting. But then they could just take a screenshot. You're right, it's a dumb idea. I won't ever build that. And here's just a little incrementer, right, where we're incrementing and printing out some sort of account. So that's just a little bit of an application you could see. But that's the basics of Memcache. So you guys have data store, putting, getting, querying. And you also will totally understand this App Engine example, which was pretty confusing on Monday. Now, that's the same one there. And now you have Memcache. And then the next folder you're going to see in here is 045 Cloud Storage, which is to put a file.
Which requires enough extra stuff. I think it may require explanation before it's assigned as a homework. I mean,
Okay.
you have to get it turned on, and then you have to go through the security loopholes.
That's true. So I'll put some homework up over spring break to deal with data store and Memcache. I'll figure something out for you.
And I'm not a bad hat at Memcache and App Engine Data Store, so if you need help, let me